Non-resident training course, September 1998, Navy Electricity Electronic Training Series, Module 6, Introduction to Electronic Emissions, Tubes and Power Supplies, Navy Track 14718. Chapter 3. Chapter 3, Power Supplies. Learning objective. Upon completion of the chart, we will be able to identify the various sections of power supplies, state the purpose of each section of the power supply, describe the operation of power supply with both of the whole unit with the standpoint from the subunit and the standpoint, describe the purpose of the various types of the rectifier circuits used in suppliers, but describe the purpose of the various types of the filter circuits used in power supplies, describe the operation of various voltage, current regulators, and power supply, trace the flow of the AC and DC and power supply through AC input to the DC output with the schematic of the diagram, identify the faulty component of the visual check, identify the problem-specific area of the power supply, and by using the logical isolation method of troubleshooting, apply safety precautions when working with electronic power supplies. Introduction. In the early part of the century for the electronics, for the first century, the most electronic equipment powered by the batteries, while the batteries allow the equipment to be portable, some of the degree of the better play with the severe limitation on how the equipment that could be used to cover the general efficiency of the battery had to be either replaced with the frequently, or if they were rechargeable, kept near the battery charge. Their advantage of having powerable equipment was more than an offset the need to replace the recharge of the batteries frequently. You only use the electronic equipment, you need the power supply with a reliable, convenient convention, cause effective since batteries fail to do safety requirements. The electronic power supply was developed, and today the Navy electronic equipment and both ashore and onboard ships require some of the type of the power supply. Therefore, the chapter is extremely important to you. Will discuss the section individual component of the power supply. Therefore, their purpose of the power supply will also discuss the troubleshooting each section of the components. Basic power supply. Figure 3.1 shows the block of the diagram of the basic power supply with a build up of the 4 basic sections: transformer, rectifier, filter, and regulator. Input, transformer, rectifier, filter, regulator. Output, and block diagram show the basic power supply. So it goes your transformer, rectifier, and then a filter, and then a regulator. As you can see, for the first section of the transformer serves the two primary purposes: setting up with the stepping down the input line voltage of the desired level. The two will comply with a couple of voltage of the rectifier section. The rectifier section converts the AC signal to pulsating DC voltage. However, you'll see that later in the chapter, the pulsating DC voltage is not desired. For this reason, the filter section is used to convert pulsating DC voltage into filtered DC voltage. The final selection of the regulator to adjust that is named implied. It means that output of the power supply contains a constant level despite the later large changes in the load current in the line put in the voltage. Depending upon the design of the equipment, the output regulator will maintain constant DC voltage with a certain limit. Now that you know that each of the sections, let's trace the signal of the power supply through the range that is made with the input signal. Figure 3.2 for the input signal with 120 volts applied with this primary transformer, which had the turn ratio of the 1 to 3. The calculate the output with the multiplying with the input voltage of the ratio of the turn of the secondary winding turn of the primary winding. Therefore, the output voltage is example of 120 volts AC times 3 at 360 volts AC. Depending on the type of the rectifier, you have the full or half wave. The output rectifier with a big portion of the input. The figure 3.2 shows the rippled waveforms associated with the full wave rectifier. The filter section contains the network of the resistors and capacitors and inductors that can control the rise and fall of the time of the variable signal so the signal remains in a more constant DC level. You will see the more clearly we discover the actual filter circuit. So you can see the output of the filter at 180 volts DC level at the AC ripple voltage riding it, and the ripple voltage is small AC voltage riding the DC voltage level, and only the ripple voltage where it will be maintained approximately 180 volts DC load. Block diagram of the power supply: 120 volts AC, the transformer 360 volts AC with 140 volts DC, 180 volts DC, and then either like a filtered 100 volt DC, so it's more direct, and then you get your 140 volts DC on the load from transformer from the regulator to the load to regulate the 180 volts DC. The transformer has several purposes. In addition, with the coupling with the AC signal with the power supply, also initiated the electronic power supply with external power source that either steps up or steps down the AC voltage divider desired level. The additional most input transformer step down windings will supply filament voltage, both power supply and the tube's external equipment. The load with the size of the transformer is shown in figure 3.3. The cover the input transformer located in the power supply with the ultimate source of the power, both of load and power supply, is called the power transformer. Note the transformer has the ability to deliver the 6.3 to 5 volts AC with the filament voltage of electron 2. The high voltage winding of 1 to 3 step up winding delivers the 360 volt AC AC to the rectifier. The transformer also has called a center tap. The center tap provides the capability of dividing 2 high voltage outputs to one transformer. So the center tap that is in between the 360 volt AC with given 6.3 volts AC transformer 1, 2, 3 step up from 120 volts AC stepped up two times, so 360 volts. Rectifier. The previous discussion, of the rectification chamber, the AC volts to pulsating DC voltage. Now let's discuss the rectification. Since the diode vacuum in the tube will pass through the only one direction, the ideal suited for the converting and alternating current with the direction AC voltage is applied with the diode. The diode will conduct only during the positive alteration on the voltage, but in the plate of the diode is made with the positive with respect to the cathode. Figure 3-4 show that the diode connected across the 100 volt and 20 volts AC line during the positive alteration from the source of the voltage. The same way to apply with the tube of the plate and become the plate positive with respect to the cathode. At the time the diode conducts the plate current flow with the negative supply lead, though the milliampere through the tube and the positive supply lead indicate the shaded area of the output waveform. The current exists during the entire period of the time that the positive plate is positive with respect to the cathode in the first 180 degrees of the input sin wave. Shows the 142 volts AC going to multiplier MA into your your diode rectifier volt one plate and cathode, reducing 180 to 360 cutoff. During the negative alteration plate, the voltage of the data polarity time the plate is driven the negative of the tube cannot the conduction prevents the tube from conducting. The tube is said to be in the cutoff. This indicates the data waveform in the tube. The cutoff, no current will flow with the entire negative alteration. The 360 degree AS cycle, the input voltage of the tube conducted 180 degree and cut off with 180 degree of the current circuit current, therefore appearing with a series of positive pulses shown to the shaded area. Notice that although a current is formally pulse with form of pulses, the current always flows through the circuit in the same direction. The current flows within the pulse in the same direction, called pulsating DC. The diode has a rectified in the input voltage, and although the principle of the rectification apply with all the rectifier circuits, some of the rectifiers are more efficient than others. For this reason, we'll expand the three rectifier circuits most commonly used with electronics today: half wave, full wave, and bridge. Practical half-wave rectifier. Figure 3.5 the two-plate diagram complete with a half-wave rectifier with a diode V. The rectifier that must be connected to the series of the load device or the resistance of the load resistance of the circuit through the direct of the current flow of the basic Navy electronic equipment. Various input voltage necessary to have the rectified voltage of the greater or smaller. Some cases, the sum of the source of the voltage rectifier plate circuit is supplied from the step-up to step-down transformer. Note that the transformer have the two secondary windings mentioned earlier. The lower winding supply with the high voltage and the plate cathode diode with the upper winding supply with the low AC voltage filaments for the diode. There's all the cathode of the diode connect for the secondary winding of the transformer through the load resistor, and you have the current flowing through the tube that is also flow through the load resistor, causing the voltage to be developed across the magnitude voltage developing across the load resistor is directional proportional amount of the current flowing through it, or ohms. Low voltage equal to amps times ohms. Figure 135 shows the half-wave rectifier, 120 volt fuse 1, switch 1, transformer 1, iron core. The transformer 1 going to the cathode heat, and then the plate from the voltage going back across the transformer, positive and negative, through a road in the circuit of resistor load, and then your voltage output. You will better understand the operation of half-wave rectifier circuit with the redrawing of the form of the simplified circuit. As you can see, the figure 3.6 of the diode V1 of the load resistor are in the series of the secondary winding of the transformer during the positive alteration input of the voltage secondary with the winding across the current with the diode V1 load resistor. Increase the diode tube with the load resistor with the series with the same current flow through the both of the tube of the resistor. The current and produce the voltage drop the current of the tube of the load resistor, which have the polarities shown since the plate with the resistance of the tube is only about 500 ohms. The resistant load resistor is 10,000 ohms, approximately 95% of that is 425 volts of drop the current of the load resistor. 425 volts at 95% is 404 volts, and 5% at 20. The other 5% at 21 volts across the tube. Alright, figure 3.5 shows the simplified half-wave rectifier in waveforms. Transformer 1, positive and negative, the resistor load from the voltage load, and which runs at 440 volts load at the load resistor. Then you have your diode voltage at 425 volts, peak 21 volts, percentage out of there. During the negative half alteration of the input voltage of the tube cannot conduct with no current fluid with the flow of the circuit. There's no current. The resistor low voltage of the 0 volts low. The negative alteration during the time of the entire negative volts alteration across the tube with the reason with the derived of the Kirchhoff law, which states the electronic and the voltage load is equal to the voltage supplied by voltage Voltage load is plus voltage B plus equals voltage A. The sum of the load voltage diode load voltage equal the applied voltage. Since the half-wave rectifier conducts one half of each of the cycle of the input voltage of the frequency pole with the same frequency of the input sin wave, the output frequency is the ripple frequency of the rectifier circuit is supplied with the power with the 60 Hz AC line voltage 60 pulse level with the curve of the second. Therefore, the ripple frequency of the half-voltage rectifier same line with the frequency. And see if the current imperial pole with the lights, like those obtained with the half-wave rectifier applied with the load resistant average amount of the power will dissipate over the given period of time. The average DC power of the power determine the amplitude of the pulse, the time delay between the pulse with the higher the peak amplitude pulse with less time, and the pulse with the greater of the average DC power supply with the low with the AC or the DC voltage average the voltage average. It is necessary to know the average volt of the pulse of the peak value of the illustrated in figure 37. The show of the 0.635 max, 0.385 max on the iron core, A and B peak values. Since the current of voltage wave of the half-wave rectifier are essentially the half-sim wave that will develop the conversion factor to form the average value of the discover the needs of module 2. But I know you should have the average value of the full sim wave. You should know that the average value of the full sim wave is 63.7. To its peak of the maximum value. Therefore, the average value of the half-wave rectifier, you should have multiply half the wave by 360 the value half the value of the 6.387 by 3.18 times the peak of the voltage expressed in the following equation. The average load voltage is equal to half of the normal peak value, peak value, or 3.18 times the voltage maximum, where the voltage maximum is equal to the peak value of the low voltage pulses. In most applications, the drop occurs with the rectifier tube that's small compared with the low voltage tube. They consume the voltage maximum arc equation to be used the same as the peak value of the input sin wave. Since the load current is the same wave and same wave shape with the low voltage, you can modify the equation that apply with the load current. Thus, amperage voltage, the load current is 3.18 times the amps volt maximum, where maximum amps is the peak load current. The line drawn with the rectifier wave at this point is 0.38 distance for the zero maximum. The waveform that divided the A is equal to the area B. Therefore, the current or voltage drop the cover 3 for 18 with the weak long voltage have the same effect of the load setting of the voltage current. Voltage or current. Alright, halfway rectifier, you be the transformer during one half of the cycle, therefore any of the given the transfer the less of the power developed with the transformer, you be the both halves of the cycle. In other words, to obtain large amount of the halfway transformer, the relatively larger comparison that would have to be in both sides of the cycle. You be the disadvantage line for the halfway rectifier applications require a small, very small circuit and current drain. The halfway rectifier widely used the commercial AC and DC radio receiver. The other applications where the inexpensive the voltage supply with the suffice. As you can see, that you have to study with the halfway rectifier with the type of the circuit that must be played with the limitation electronic equivalent for the reaching with another type of the rectifier circuit that has been developed. One of the factors had to be considered how to use the full output of the transformer to obtain the highest voltage of the current of the full wave rectifier was developed. The eventual full wave rectifier. The full wave rectifier is a device with the two or more die over the range of the low current flows in the same direction each half of the cycle. The AC cycle is schematic diagram. Simple full wave rectifier shown in figure 3 with the transformer supplied with the sole source of the voltage of the two rectifier tubes voltage diode 1, diode 2, or the rectifier tube 1 and 2, the power transformer center tap of the high voltage secondary 1 is divided into two equal parts, winding 1 and winding 2. Winding 1 provides source for the voltage for the rectifier 1, and the other winding 2 for the voltage 2. Voltage rectifier tube 2, the connection of the diodes, arranging the diodes connect with an alternating half cycle. Alright, this shows the AC line transformer, winding 1, winding 2, winding 1 going into the its own circuit, parallel circuit with Z1, Z1, and also sharing the same resistor load resistor. During one alteration of the secondary voltage of the polarity will show in the figure 3A with the source of the Z2 with the V2 with the voltage either into the lower half of the transformer secondary winding. The specific instant by the time shown with the figure with the plate voltage V2. Negative V2 cannot conduct. Throughout the period of time during the plate with the voltage V2 with the diode V2 with the negative of the plate with the V and diode V1 with the positive. They illustrate the polarity signs across the winding 1 indicate the voltage of the diode V1 since the plate of the diode V1 positive conductor the current flowing through the load resistor direction shown by the arrow. Figure 3.9 shows the next half cycle secondary voltage. As you can see, the polarities of winding 1 and winding 2 are reversed during the alteration of the diode plate of the diode 1. During the alteration, diode 1 cannot conduct. It's either one or the other, diode 1 or diode 2. Simple full wave rectifier second alteration. For the period of time the V1, the diode V1 is negative with the plate with the negative V2, permitting the V2 to conduct notice the plate with the V2 path through the load resist the same direction that the plate did with the V1. The circuit arrangement of the pulse loading the current flow during each of the current of the input cycle since both of the alteration input voltage cycle of the circuit are called the full wave rectifier. Know that you have the basic understanding of how the full wave rectifier works. Let's can cover the detail of the practical full wave rectifier and waveforms. A practical full wave rectifier. Practical full wave rectifier is circuit shown with the figure 310 U with the two diodes V1 and V2 and the center tap of the transformer T1. When the center tap is ground, the voltage from the opposite end of the secondary windings are 100 degrees out of phase with each other. Thus, when the voltage of the point A is the positive with respect to the ground, the voltage of point B, the negative with respect to the ground. Let's examine the operation circuit during one complete cycle. I'm going to show the complete full wave rectifier, the 600 volt, the DC signal line. We fuse the transformer 1 amplifier going to V1 through the V1 to the resistor, all equal amplitudes. Secondary voltage, load 1, 2, 3, 4, load voltage 1, 2, 3, 4. Both having 300 volts amps. So adding the parallel circuit, you'd have 600 volts instead of. During the first half cycle, they is indicated in solid arrows. The plate volt V1 is positive with respect to the ground, with the plate with the V2, the negative edge of the current flow with the ground center tap of the load resistor of the diode V1 is the point A, the transformer current flow with the point A through the upper winding of the back to the ground. The center of the amp, the V1 conducts it acts like a closed switch, so that the positive half cycle falls across the load. During the second half cycle of the broken line with the polarity would fly with the voltage be reversed down with the plate with the diode V2 with the positive with respect to the ground with the diode V1 is negative only diode V2 can conduct the current with no flow. Now flows is shown with the ground center tap through the load resistor through the diode V2 with the point B over the transistor 1. So while one's doing the other one half cycle, the other one's doing the other half cycle. One's off, one's on. All right. During the second half cycle, alright, if the transformer, the current flow of the point B with the lower winding with the back to the ground center tap known for the current flow of the load resistor of the same direction of both half of the input cycle. The outer waveform of the full wave rectifier consists of the two pulses current of the voltage, each with the cycle of the input voltage ripple frequency output with the full wave rectifier, therefore the twice the line frequency. If the higher ripple frequency of the output with the full wave rectifier with the distinct advantages because of the higher pulse frequency output with the closely approximately pure DC with the high frequency making filtering make easier of the output whole halfway rectifier. Or this show the terms of peak of the average of the current value voltage across the full wave of the rectifier with the greater average current with the voltage of the output with the full half wave rectifier. The relation between the peak and the average is illustrated in figure 311. 311 show the peak of averages, the 636.3 max efficiency power, and then B, and A would be above that, and B would be your peak performance under that. So the output waves are essential with the similar to both alterations, same polarity, average of the 63% for the peak current voltage as an equation of the amperage voltage, 63 points the voltage max. For voltage max, the peak value of the load voltage pulse, and the amperage voltage load current is 63.7% maximum, and wherever the voltage amperage peak load with the current pulses. Example, the total voltage across the high voltage secondary with the transfer supply with the full weight rectifier 600 volts, find the average loading voltage, but ignore the drop across the rectifier tube. Since the solution of the total secondary voltage 600 volts, either diode supplied one half of its value with the 300 volts. The secondary voltage, the root mean squared value of the peak load is this. Voltage max is equal to 1.414 over the voltage. Secondary voltage max is 1.41 times 300 is 424 volts, and the average load of the resistor is the add voltage resistor of 6.3 point times the voltage max. It gives you an average voltage of 270 volts. No, if you have any problem with the equation of the review of the Neets module 2 pertaining to this equipment area with it, as you may recall the past study of electricity, the average of the disadvantage of the average circuit with the full wave rectifier, no consumption started with the full wave rectifier found without the other frequency, double the average volts with the double, resulting in the signal much easier filter because of the high frequency ripple frequency. The only disadvantage of the peak voltage of the full wave rectifier, only half of the peak voltage with the half wave rectifier, thus becoming secondary to power transform the full wave rectifier center tap, though therefore only half of the source of the voltage goes to each of the diode. Fortunately, the rectifier produced the same peak voltage with a half-wave rectifier with the same ripple frequency of full-wave rectifier. The circuit is called the Bridge Rectifier. This will be in the chapter of the chapter of the next discussion. Bridge Rectifier. The four diodes connected to the shown figure 312 of the circuit called the Bridge Rectifier. The input of the circuit is applied with the directly opposite of the corner of the network, and the output taken the remains in two corners. Or say if you're cut off, and then you have your two peaks, and then two peaks, and then one cut off as you see the transformer 1, and then you have voltage diode 1, 2, 3, 4 in a series, almost like a winding, but it's in a four-way series with a resistor load. And number 5 would be your full peak DC pulsating during one half of the applied voltage at the point of the A become with respect to the point B, with the amount of the voltage increased with the secondary with the transformer during this time of the voltage between the point A and the B is considered to be impressed the voltage diode 1 V1 load resistor the load resistor on the V diode V3 and the series of the voltage applied with the cross tubes makes up the plate with more positive and the cathode the current flow from the point B through the tube V1 with the upper direction of the cross load resistor through the diode V3 to point over the path indicated with the solid area of the waveform as shown in figure 1 and 2. 1/2 cycle later, the polarity occur for the secondary reverse the place of the diode 1 and diode 3, negative with respect to the cathode, same time the volt place of the diode 2 and diode 4, become positive with respect to the cathode current flow with the direction indicated with the dash area of the current through the resistor load, always the same direction of the current flow, and the resistor load resistor develop the voltage corresponding with the showing in the waveform 5. The bridge rectifier is a full wave rectifier, certain current flow with the load current during the both halves with the applied with the alternating voltage. One advantage of the bridge rectifier over the conventional full wave rectifier is that within a given transformer, the bridge rectifier voltage output nearly twice of the conventional full wave circuit, and we can show the assigned value to some of the components as shown in figure 313 view A and B. Assuming the same of the transformer, the transformer achieve the both circuit. The peak voltage is developed in position X and Y as 1,000 volts in both circuit. The conventional full wave circuit value with a peak voltage center tap of the X and Y with 500 volts. Since only one diode can conduct the instant maximum voltage can be rectified instant to 500 volts. Therefore, the maximum voltage appear with across the load resistors nearly never exceeds 500 volts. Because of the small voltage drop of the cuff of the tube, the bridge rectifier view B with the maximum voltage can be rectified fully secondary. A full secondary 1,000 volts. Therefore, the peak output voltage across the load resistor is nearly 1,000 volts. Thus, for the both circuits be the same transformer, the full wave bridge circuits produce the higher output voltage of the conventional full wave rectifier. Alright, so you have 500 volts. This would you're on your bridge, you'd have 1,000 volts. Over here, you'd have 500 volts. Alright, your second advantage of the bridge rectifier with the low voltage peak and the inverse with the voltage average of the output with the reverse reason for the bridge rectifier vacuum tubes are widely used for the high voltage power supply applications. In direct heated diode with the bridge rectifier 3 support separate filament transformer that require to do the different potential of the existing filament in the diode filaments for the diode 2 and diode 3 of the figure 314 same potential of the element with the diode 1 with the different potential from across either diode 2 or diode 4. 3 filament transformers must be insulated with each other from the ground because of the high potential with which they are subjectively used and indirectly heated diode with which solve the filament transformer problem. The high potential difference between the cathode heater would be likely resulting in arcing. 314 show the bridge rectifier transformers, show the transformer in voltage V1, V2, V1, V2, V4, 3, V4 transformers to each one of the parallel connections between each of them, and you give it an average voltage and single phase power. Alright, your filters. Without rectifier with the pulsating DC, most of the electronic circuit requires substantially pure DC for the proper operation. To the type of the output provided with the place for the signal multiple section filter between the output of the rectifier load are the 4 basic type of the filter circuit: the simple capacitor filter, your load capacitor choke input filter, load capacitor input filter PI type, the resistor capacitor input PI type. We'll cover the function of each of these filters in detail later in the chapter. The filter is done with the use of the various combinations of the capacitors, inductive resistors, inductors are using series impedance to do opposed with the change of the following and the alternating pulsating DC current. The capacitors use the elements bypassing alternating components with a single round with the load to the ground. Resistors use the place the inductors to the low current application. Let's briefly Review the property of the capacitor. The first capacitor opposed to any change of the voltage. The opposition change of the voltage capacitation of the reactance or XC. Measure in ohms. Thus, the capacitation reactance is determined by the frequency applied with the voltage and capacitation of the capacitor. So the capacitive reactance is equal to 1 times the 2 times the pi times the frequency times the capacitation. Simple formula for the frequency of the capacitation with the capacitation reactance will describe the sum of the filter capacitation player well the low of the filter the capacitation reactance is provided with a better filtering than the higher capacitation reactance, the done with providing better shunting effect of the AC around the load in shown figure 315. Alright, your first charge time show the power supply with the capacitor 1 charging path from the ground. Capacitor 1 is grounded, load and it's grounded. The charge path goes to power supply, and then capacitor to the ground, capacitor to the load, ground. Power supply discharge path goes from the load, ground, capacitor 1, load, pound, and both ground follows both grounds. Or to obtain the steady DC output of the capacitor must sharpen the almost instantaneous value applied with the voltage on to the charge of the capacitor and remain the charge long as possible. The capacitor must have the short time charge time kind of the constant, the longer the distance time constant VUB. This can be done by keeping the internal resistance of the power supply as small as possible, fast charge time, and the resistant load charge as possible, slow discharge time. For this earlier study of basic electricity, you remember the one capacitor time consistent defined the time the capacitor charged at 63.2% applied with the voltage discharged at 3 to 6.8 percent. So this was expressed in the following equation. The time is equal to where the R is the representative of the resistance of the charge of the discharge pass, and C times C with C representing the capacitation of the capacitor. You should also recall that the capacitor is considered fully charged after 5 resistor capacitor time constants. Refer to figure 316. You should see that to obtain steady output DC output voltage, the capacitor should charge rapidly and discharge as slowly as possible. Alright, show the resistor capacitor time constant sharp for intervals of 5. The 36.8 is your total charge, and then your then 63.2 would be your applied voltage, and then it goes up to 100% charge. In filter circuits of the capacitor, common element both for the charge and discharge path. Therefore, obtaining the largest possible discharge that you want to obtain the largest possible. Another way to look at it, if the capacitor acts with the short circuit around the load, as far as the AC component is concerned, is since the reactance capacitive reactance equals 1 times 2 times the frequency times the capacitation, and a large value of the capacitor, small opposition of the capacitive reactance resistance to the AC. Now let's see the inductor for the application for the filter circuit. Remember the inductors oppose any change. Inductors oppose any change in current. In case they have forgotten the change of the current through the inductor produces the changing electromagnetic field. The changing of the terms causes the wiring the inductor, thereby producing the counter electromagnetic force. The counter electromagnetic force opposes the change of the circuit current. The opposition of the current change of the current give the frequency called the inductive reactance, or XL, measured in ohms. The inductive reactance is the inductor determined by the applied frequency inductor mathematically. Inductive resistance is 2 times the frequency times the load, Following the preceding the formula, you will now have either frequency inductance increase the inductive reactance will increase some of the inductor play for the shear of the load of the inductor reactance larger than the AC voltage developed. The inductor smaller than the AC voltage developed across the load. 317 show the voltage drop of the inductor filter power supply. The voltage AC just drop is in a transformer from positive to negative. The heavy capacitor looks up the positive to negative. Load smaller than voltage GC drop. Now that you're back in this to our circuit, that is illustrating figure 318 with the current flow through the coil with the expanding magnetic field builds up the inductor with the magnetic fields around the coil develop the counter EMF with the pole with the change of the current with the rectifier current decrease as shown in the figure 319. Magnetic field collapse again, cut the turns winding of the wire with inducing the current into the coil with addition current at the rectifier current with the attempt to keep the original level. So the inductive filter is the counter EMF force going from the load back into the power supply of the expanding magnetic field of the load 1 at the capacitor 2, 1 being the also grounded. Alright, load 1 collapsing magnetic work from the load going into the power supply. The inducer force collapse of the magnetic field. Now that they have learned with the components of the filter circuit, they react with the current through the rectifier. Let's discuss the different type of filter circuits used in today. The capacitor filter. Symbol of the capacitor filter, most basic type of the power supply for the filter. The sweep of the filter of the very limited, sometimes even the extremely high voltage, low current power supplies and cathode ray and similar electron tube. The very little road current through the supply of the filter is usually the circuit with the power supply ripple frequency circuit critical that can relate relatively high. Simplify the filter is shown figure 320 with the considerable single filter element. The capacitor is C1 connect the across the output of the rectifier parallel low of the rectifier resistor capacitors RC charge time. Remember the filter capacitor must be short, but the RC discharge time must be long enough to eliminate the ripple action with the filter. In other words, the capacitor must charge the up as fast, preferably charge up as fast as probably no discharge at all. But if better filtering also resolve the frequency in a high, therefore full wave rectifier output easier to filter with a half wave rectifier between the high frequency rectifiers. Alright, transformer 1, fuse 1, going to the ground of dial 2, grounded, and V1, V2 going to capacitor 1 and resistor grounded. Do you understand that these affect the filter of the voltage out of the compared with the rectifier circuit without the filter figure 321, those filter of the figure 322 output waveform of the figure 321 represent an unfiltered output for the half-wave full wave rectifier circuit with the current pulse through the load of the right load resistance. Each time the diode comes out for the dish, indicate the average load value of the output voltage for the half-wave rectifier, the voltage average left at half of the peak of the output voltage, approximately 3.18 over the peak output voltage of the full wave rectifier at voltage approximately 0.33. This is the value is so much for the applied voltage or the percent. The no capacitor connected across the output of the rectifier circuit with the full wave forward large pulsating component ripple compared with the average current. Now that they refer to figure 322. When the capacitor is connected across the output in parallel with the resistor load, the average of the voltage output with the average voltage is increased due to the filtering action of the capacitor. So you have switch 1, fuse 1, transformer 1, voltage regulator 1, resistant load rectifier, half-wave rectifier shows 1 cycle, 3.18 voltage average. And then you have the full wave rectifier, which is split with the center tap in the transformer from switch transformer 1 and voltage 1 and voltage 2 resisting load on a circuit and complete circuit also resisted with a resistor load that's grounded. Or your half-wave rectifier shows a single switch fuse, the transformer, the real rectifier with the capacitor resistor load that's RC. And then your RC full wave rectifier shows this transformer 1, visual 1, capacitor and resistor load as 3.1 average for your half-wave rectifiers, and then double that and you'll get your full wave rectifier average. The value of the capacitor fairly large, double the microfarad with the presence of the relatively low resistance pulsating clearance store with the substantial charge with the rate of the charge of the capacitor limited only relatively low resistance of the conducting diode with the RC charge or resistor capacitor charging time of the circuit is therefore relatively short as a result of the pulsating voltage first applied with the circuit with the capacitor charge is rapidly with almost charged to the peak of the value of the rectified voltage any time of the diode conducting tends for the retain the change charge with the rectifier outputs of the zero with the capacitor cannot discharge immediately. The capacitor slowly discharge though the load resistance during this time the rectifier is not conducting the rate discharge of the capacitor to determine the voltage of recapacitation, the voltage of the load resistance, the capacity and the load resistance value of the large of the resistor capacitor discharge time of the circuit is relatively long. The waveforms shown in figure 322 show the additional capacitor 1 and circuit as a result of the increase of the average voltage output voltage of the average voltage reduction amplitude of the ripple current of the voltage resistant present across the load. Resistant load considered with a complete cycle operation of the halfway rectifier of the capacitive filter C1 and load resistor RL. Is shown in figure C23. The capacitor is assumed to be large enough. For capacitor 1 is assumed to be large enough. The small reacting with the pulsating rectifier of current. The resistant load resistor is assumed to be much greater than the reactance of the capacitor 1 and the input frequency. Alright, half-wave rectifier capacitor filter. Capacitor discharge fuse. You have when the circuit is energized, the diode conducts positive half cycle. The current flow through the circuit allowing capacitor 1 to charge. The capacitor 1 is then so you get a half a charge off your half a wave or a 90-degree sim wave. But that would be half a DC charge. So. The C1 will charge approximately the peak value input voltage of the charge left in the peak value of the voltage drop of the curve of the diode V1 the charge of the Z1 indicated the heavy solid line of the waveform. Illustrated figure 321, 324 of the diode cannot conduct with a negative half cycle together with the plate of the Diode V1 is negative with respect to the cathode. During the internal interval, the capacitor D1 discharges the load resistant to the discharges through load of the resistor the load resistance of the RL. The resistor of the discharge of the capacitor produces the downward slope, indicating the solid line of the waveform in shown figure. 230-24 show the half-wave rectifier capacitor negative input cycle. The capacitor discharge time, the amount of the capacitor discharge time. Alright, during the discharge period, the constant rep fall will be applied with the AC voltage with the peak value 0 with the voltage across the capacitor 1 across the resistor load. Load resistor gradually increases the time of the next half cycle with the Bridge Rectifier operation. Keep in mind with a good filter capacitor, there should be charged with this fall as fast as possible and discharge as little as possible. Since practical value of the capacitor and load resistor ensure more or less of the gradual decrease of the discharge voltage with some substantial charge remain of the capacitor time in the next half cycle operation result no current flow through the diode until the rising in the AC input voltage. Play with the diode exceed the voltage of the charge with the remaining in the capacitor of the capacitor 1 charging the capacitor 1 cathode potential of the diode with the potential plate exceed the potential of the cathode of the charge of the capacitor 1 the diode again to conduct for the capacitor 1 condenser charge approximately peak value of the applied voltage. After the capacitor has peaked in value, begins to charge the fall of the AC input with the voltage plate with considerably more rapidly increase the capacitor voltage of the quickly becomes more positive the plate when the diode ceases to conduct. The operation simple capacitor, the filter, even the full wave rectifier, basically the same in the operation. Discover the full wave half wave rectifier, knowing that 325 becomes one with the diodes always connecting, acting on alteration full capacitor, chart of the discharging each of the half cycle. To note that each of the conductor diode conducts half the portion of the time the post secondary peak secondary voltage is greater than the charge across the capacitor. We stated before the nature of the aim for the full wave of the Bridge Rectifiers over the half-wave rectifiers, easing the filter over the output voltage. Now you can see the reason the ripple frequency doubled, therefore the time of the period that applied with it is discharged is cut in half. The means of the capacitor discharge, then the ripple amplitude is less, and smoother output voltage occurs. Anything to keep in mind with the ripple component of the total voltage total of the output voltage of the AC voltage of the average of the voltage average of the DC output component of the output filter capacitor off with the relatively low impedance of the majority of the AC component flow through the filter capacitor. The average the AC component thereby for bypass or shunted around the load resistant entire DC component or the average or DC component or voltage average flow with the load resistant carefully stating that let's take a look at the capacitive reactance in the half wave and the full rectifier first to establish some of the values of the circuit. Half-wave rectifier frequency rectifier at 60 Hz value with a capacitor value with a filter capacitor at 30 amplifier frequencies load at 10 kiloohms would be 1 over 2 times pi times the frequency times the capacitation for infrareds, or we get 0.159 as your over 60 times 0.00030 or 83.08 ohms. Your frequency output at 128 G's, fill filter to 30 microfarads, load resistant 10 kills will give you 44.16 ohms. As you can see, the calculation of the output frequency rectifiers double the impedance for the capacitors, reduced 1/2. Therefore, the simple capacitor filter is used in combination with the low-wave bridge rectifier, improve the filtering and provide with the increase of the variable frequency, decrease the capacity of the resistance active of the filter capacitor of all the capacitor components to be passed through the capacitor more easily. Therefore, output of the fully rectifier is such easier to filter than 1/2 of the rectifier. It should be obvious for the smaller with the capacity reactance of the filter capacitor, respect the load resistance for the better with the filter action, larger possible capacitor, we achieve the best filtering. Load reactance also is important consideration. Load resistance is made small, load resistance current increase the average volume of the output voltage, or voltage output voltage average decrease the RC of the resistor capacitor discharge time constant, direct function of the value of the load resistance, therefore the rate of the capacitor voltage discharge, the direct of the function current through the load, the greater load of the current, the more rapidly with the discharge of the capacitor, the lower the average of the output voltage of the issue. The same capacitor filter is seldom used when the rectifier circuit must be very relatively low current. In general, we supply the voltage cuff and the input with the filter circuit with a one terminal filter capacitor can be connected to the other from the circuit. Alright, caution. Remember the undischarged capacitor retain the polarity hold with the charge of the low and sphere of the time. Be sure of the proper safety shorting of the probe of the discharge of the capacitor to be tested the power off before the connecting and testing equipment the disconnecting the capacitor. You can check with the capacitor, even the capacitor, then analyze it to determine the effect of the capacitance leak with the resistance. During the check, the very important to observe the correct polarity. If the capacitor electrolyte with a decrease of the capacity load of the capacitor can cover the output to be normal to cover the excessive ripple amplitude. A suitable capacitance analyzer is not available. You can get an indication of leakage resistance over the ohmmeter. We can make the resistance measurement across the terminal for the capacitor to determine whether it's ordered, leaked, or open the test electrolytic capacitor for the ohmmeter, high range for the connect of the test probe across the capacitor. Be carefully observe the polarity of this information with the current flow for the electrolytic capacitor of the option with the one direction, with the other. They observe the incorrect polarity. Observe the correct polarity. You will get an incorrect reading. You may damage the meter. You will first connect the test probe. Large deflection of the meter show the place. The pointer should return slowly toward the infinite the position of the capacitor. Chart with a good capacitor rated working. 450 volts DC. Final reading on the ohmmeter should be 500,000 ohms over. Low voltage electrolytic capacitor should be indicated approximately 10,000 ohms. An ohmmeter does not deflect when you make the resistance check. They explained above that you found the open circuit of the capacitor. A steady full-scale deflection point of 0 ohms indicated by the capacitor being tested, and short indication of leak capacitor steady reading of the scale somewhere between 0 and the minimum acceptable value. Between the reading is not scaled with the in-circuit shredding portion and part. The value of the capacitor check should be made with the capacitor completely disconnected with the circuit with which it operates. Alright, high voltage filter capacitor application paper, oil filter capacitor, doing the engine for the magnetic and the ceramic capacitor for the low ceramic value. In this case, the polarity, no amateur important U for the capacitor terminals marked plus and the minus. However, the good maintenance of the provided the U of the time output polarity with the curve barriers, the circuit of the connecting top of the positive, negative of the animated verse for the polarity with the circuit testing and with the minimize the possible damage of the component of the test equipment eliminated. Alright, your load resistor. Your induction, the LC choke input for the LC choke input for the primary power supply with a good voltage regulation input where the output with relatively subject to the load conditions. This with the filter, you for the high power application start to find the radio communication transmitter power supplies. Figure 326, you can see the filter consists of an input inductor, the filter choke, the L load resistor 1, and the output load induction 1, and output capacitor 1, resistor load diode 1, do full wave rectifier. Center temp transformer 1 grounded. The inductor L1 is in place, and then the input of the filter here with the output of the rectifier circuit to see the additional action inductor to oppose any change of the current flow. The inductor tends to keep the constant current flowing through the additional load through the complete cycle of the applied voltage. As a result, the output voltage never the reach for the peak value of the applied voltage. Instead, the output voltage approximately average value of the rectified input of the filter is shown in figure 327. Input form the full rectifier LC choke induction capacitor choke input filter capacitor resistor load input the 1/2 cycle average resistance reactant for the inductor XL reactant for the inductor implied with the amplitude of ripple voltage reducing the DC output voltage appreciable amount. The DC resistance of the inductor is just a few ohms. The shunt capacitor for the capacitor 1 charge for the discharge frequency rate, ripple frequency rate, amplitude for the ripple voltage of the ampage voltage rippled relatively small. Voltage for the resistor relatively small because of the inductor 110 to keep the constant current flowing in the rectifier circuit to the load. In addition to the resistance of the shunt capacitor, the capacitor reactance. Present low impedance with the ripple the component of the existing output filter, then the shunt to ripple the component with around the load. Capacitor attempt to hold the output voltage relatively constant with the average value of the voltage. The value of the filter capacitor 1 must be respectively relatively large resistance of the low capacitive reactance to pulsating current to destroy the substantial charge of the rate of the charge of the capacitor limited to low impedance for the AC source for the transformer small resistance of the diode and the counter EMF developed by the coil. Therefore, the resistor capacitor charging time constant is shorter compared to the discharge time. Alright. As a result, with the pulsating voltage of the first supply with the load induction capacitor choke input filter, the inductor filter choke L1 produced the counter EMF above with the constant increase of the input voltage of the net result of the defect of they prevent the rapid discharge of the filter capacitor C1 instead of the reaching the peak value of the input filter capacitor 1 only show the average value of the input value of the input voltage reach of the peak and decreases sufficiently the capacitor 1 attempt to discharge through the load resistor and capacitor 1 attempt with the discharge induced indicated in figure 329 because of the relatively low discharge time constant. Capacitor 1 can only partially discharge. Capacitor discharge time and amount of the discharge. So this is your full wave rectifier, inductor, capacitor, resistor, and all right, the large and its discharge path. The large value of the filter capacitor, but of the filter action, however, due to the physical side of the practical limitation for the maximum value of the capacitor, the inductive filter choke will maintain the current flow of the filter output of the capacitor C1 and load resistor RL, normally constant during the charging discharge periods of the filter capacitor. The series inductor L1 and the capacitor C1 for the voltage divider with the component ripple applied with the input voltage shown figure 330 far it's possible ripple with the component with the concern with the inductor offers the high impedance, capacitor offers low impedance as a result of the ripple with the component of the ripple component voltage resistance appear with the across the load resistance greatly tended to reduce since the induction of the filter choke will oppose the volt value of the current flow through it and the average value of the voltage proceeds across the capacitor containing much smaller value of the ripper component of the voltage resistance as compared with the value of the ripple across the coil. 330 show the induction capacitor choke input filter as in voltage divider. The L1 in your induction coil 1, capacitor 1 on the resistor load. The AC component equals this the high impedance for the load 1 over the resistor 1 and with split with the resistor 1 and capacitor 1 low impedance. Now let's look at figure 331. We'll illustrate the complete cycle of the operation where the full rectifier circuit is issued with the supply of the input voltage of the filter with the rectifier voltage developed across the capacitor C1, the ripple voltage output of the filter alternating component of the input voltage reduced and amplified filter section. Alright, so you have your filter section action of the inductor capacitor choke input. Show the full wave rectifier with the induction coil L1, capacitor 1, resistor 1, average voltage, and the peaks and having full AC sim wave on one being rectified into a DC and then actually tuned, filtered in this and over here the average. Each time of the plate with the diode goes positive with respect to the cathode, the diode conducts the capacitor 1 chapter chart. The conductor occurs with the twice during each of the cycle of the full wave rectifier 60 Hz applied with the reduced the ripple frequency to 120 Hz. Although the diodes alternate, one conducts while the other non-conduct the filter input of the value of the downside of the A as the plate voltage of the conducting diode and the pose with the half cycle has to see when the charges the charge being limited by the impedance of the secondary transformer of the winding diode. Forward the cathode is the plate resisting the counter EMF developed with the choke during the non-conductive interval of the plate with the voltage of the drop the load of the capacitor charge with the capacitor 1 discharge the load resistance opponent with the discharge the coil with the load time resist the charge 1 discharge the slower than it charges. The choke L1, the inductor the choke L1, inductor L1, usually large value of the order of the 100 to 20 henries offer the large inductance tree of 120 Hz ripple component to reproduce. The rectifier, therefore, in effect of the inductor of the L1 has been charging the capacitor C1 must be considered, and the inductor L1 is connected in series with the parallel branch of the connectors. Capacitor 1 and load resistor and the division with the ripple AC voltage with output DC voltage occur with the greater impedance of the choke less ripple voltage the capacitor 1 output. The DC output voltage is fixed mainly by the DC resistance of the choke. Now you have ready for the now you have read how the inductor capacitor choke input filter function. Let's take a look at the actual components of the simplicity and frequency. Primary transformer with 117 volts, 60 Hz will be the halfway of the full wave circuits with the provided input filter. Showing the halfway configuration shown in figure 323 and 332. The basic parameter of the 170 volts at the arcs root mean squared applied with the transformer 1 primary, 165 volts AC peak to peak and available with the secondary 117 volts times 1.414 gives you 165 volts. You should recall the ripple frequency at half wave cycle rectifier 60 Hz. Therefore, the capacitive reactance of the capacitor 1 is capacitive reactance is equal to 1 times 2 times the frequency times the capacitor microfarads, which give you 1 times 10 to the 6 over 3.3768 or 265 ohms. And this is they show the 175 volts A660 volts going through the diode, 10 henries at the induction and 10 microfarads, and then a resistor at 10 kilo ohms. This means the capacitor C1 offers the 260 opposition resisting ripple current of the node that however the capacitor is often the independent impedance of the direct current of the inductive reactance as the of L1 is the conductive capacitive inductance is 2 times 5 times the frequency times the ohms or 3.8 kiloohms. Showing that the inductor L1 offers the relatively high position 3.8 kiloohms of ripple with a comparison with the opposite offered the 260 capacitor 265 ohms. Most ripple voltage with a drop across the inductor 1 then across the capacitor 1. In addition, the impedance of the capacitor 651 265 ohms is relatively low respective of the resistance of the load of 10 kiloohm. Therefore, most ripple current flow for the capacitor 1 with the load of the other one capacitor shuns most of the component around the load. Let's go a step further with the redraw of the filter circuit that, as you can see, with the voltage divider action figure 333. Remember the 160 volts peak to peak 60 Hz provided with the rectifier consists of both AC and DC components. Further discussion about the AC long. Looking further, figure 3.3, see the capacitor 1 offer the least amount of the 265, least opposition 265 ohms for the AC component. Therefore, the greatest amount of the AC will flow through this capacitor 1. The heavy line indicated the current flow through the capacitor. The capacitor bypassed the shunt most of the AC around the load by the combining the capacitive reactance of the capacitor 1 and resistance load. The resistance of the load resistor is then the equivalent circuit that will have the equivalent impedance of the 265 ohms. This shows the impedance of the resistor resistance times the capacitive reactance over the square root of the resistance squared times the capacitive reactance squared, or the inductive chemical coil with the capacitor resistance 1 and 265 ohms, 3.8 and 10 kiloohms that were used. You now have the voltage divider shown with figure 334. You have the, see because of the impedance of the rate with the larger amp of the ripple the voltage with the drop off of the inductor 1 L1 substantially smaller amount of the drop of the capacitor 1 of the load resistor. You can further increase the ripple voltage by inductor 1 by increasing the inductance. Now let's discover the component of the applied voltage. Remember the capacitor offers with the infinite impedance of the flow direct current of the DC component. Therefore, by flow of the resistor, the load resistor with the inductor will 1 as far as the DC is concerned. The capacitor does not exist the coil and the load. Therefore, in the series with each other, the DC resistance or filter choke at the first very low 50 ohms average. Therefore, most of the DC component developed across the load and very small amount of DC voltage dropped across the coil, and shown in figure 335. 335 show the DC and the inductor choke, capacitor choke input. As you have mentioned, both AC and DC components flow with the inductor 1. They kept the coil frequency sensitive to the power of the large resistance to the AC, small resistance to the DC. In other words, the coil opposite of any charge the property make for the coil higher desirable filter component. The filter action of the inductor capacitor input the filter improve the filter with the unit conjunction. The full wave rectifier shown in figure 336 due to the degree of the capacitive reactance filter with the capacitor increase the voltage the capacitation reactance, the load resist reactance. Remember the ripple frequency full wave rectifier 12 for the full half-wave rectifier 60 Hz, and the ripple of 120 Hz. The briefly the capacitive reactance is C1 of the capacitor 1, and the capacitive load resistance load reactance of the L1 is capacitive reactance would be 1 over 2 times the microfarads times the capacitation. It would be 132.5 ohms. Then your load would be 7.5 kiloohms. Alright, 336 shows the full wave rectifier with the LC choke input filter, induction coils, capacitor resistance grounded, V1, V2 for tap 1, center tap grounded. It should be apparent that the capacitive reactance of the filter capacitor to create the power with less opposition flow of the AC with the greater loads than the AC through the capacitor is the lower through the load. Conversely, with the large of the load reactance of the choke with the greater amount of the AC ripple developed across the choke, the constantly less ripple developed across the load. The condition provides better filtering. A inducting capacitor choke input filter. Several problems that can go over the failed filter capacitors are shown with the open circuit short circuit itself. The leads the series inductor a series of open show with the open windings. The occasional short term with the short circuit to be occur to the core filter capacitor choke input filter circuit is not subject to extreme voltage shorts because of the protection offered by the inductor. Have the capacitor can become leakly or shorted. Shorted turns in the choke may reduce the voltage inducing inductance might become a low vertical version of those result in excessive peak rectifier current with the accompanied by the abnormally high output voltage and excessively ripple amplitude of the poor voltage regulation changing choke winding of the out opening of the choke winding that is shorted with the core with the result of the no output condition. The choke winding is shorted with the core may be cause overheating of the rectifier element, blown fuse, so forth. Check the capacitor filters, remove the applied voltage input with the filter circuit with it, disconnect the one terminal with the capacitor with the circuit, then the capacitor with the capacity, analyze the term of the capacity and leak resistance of the capacitor with the electrolytic. Be sure that you the current polarities at all times decrease the capacity and load of the capacitor can be decreased with the efficiency of the filter pursues the excessive ripple amplitude. Suitable capacitation analyzer is not available to use the almeter to check the leakage. Resistance test procedure is the same as described in the input capacitation filter. So far, the section has discussed the detailed operation troubleshooting the mace inductive and incapacitating filter circuit. The remaining two types of filters will discuss the difference between them and the other basic filters. Alright, resistor capacitor filters, and we're going to cut the tape there.